Hello, I'm Mrs. J, and today we're going to graph rational function constant over linear and then linear over linear. So for the first one, constant over linear, they want us to graph the vertical and horizontal asymptotes first. So remember, for vertical, you need to find the domain. And the domain is whatever gives us 0 in the denominator. So x cannot equal -1. Since this doesn't reduce, we have a vertical asymptote at x equals -1. For the horizontal asymptote, you look at the degree. The degree on the top is 0, and the degree on the bottom is 1. This is a constant, so the degree is 0. And this is x to the first, so the degree is 1. When the degree on the bottom is larger, the horizontal asymptote is y equals 0. So that means for our graph, our horizontal asymptote is on the axis. Our vertical was at -1. So that's the first thing you want to do. And then you want to make sure that you graph 2 points on each side. So we could, let's see. On this side, this is -1. I could plug in a -2 and a -3. On this side, I can plug in 0 and 1. Remember, y is 2 over x plus 1. So when we plug in 2 over -2 plus 1 is 2 over a -1 or a -2. Two over -3 plus 1 is 2 over a -2, which is -1. Plugging in 0 is 2 over 1, or 2. And plugging in 1, 2 over 2 is 1. And then you would just tell it these points. So -2, -2, -2, -2, it's here. -3, -1, 2, 3, -1. And then 0, 2, 0, 0, 2. And 1, 1. Now your graph's going to approach these dotted lines. It will not cross them. Once in a while you cross a horizontal, but not when it's a constant on top. And there's your graph. So once you plot these 4 points, then you'll just hit the graph and it will graph it for you. Let's try another one. Same one. Okay. So domain. -x plus 2 equals 0. Adding the x over 2 could not equal x. So we have a vertical asymptote at x equals 2. Degree on the top is 0. The degree on the bottom is 1. So we have a horizontal asymptote at y equals 0. So Y equals 0 is our horizontal. Our vertical is at 2. So we need to plot points. For x, we could plug in going this way, 1 and 0. 1, 0. Going this way, 3 and 4. So we plug them in. Plugging in 1, we have a -7 over -1 plus 2 is 1, which gives us -7. Plugging in 0, -7 over 0 plus 2 is 2, so it's a -7/2, which is a -3.5 for graphing purposes. Plugging in a 3, we have -7 over -1, which gives us 7. And plugging in 4, -4 is a -2, which gives us a +3.5. So those are our points. 1, -7, so it'll be way down here somewhere. 1, 2, 3, 4, 5, 2 more. 6, 7, right there. 0, it's at -1, 2, 3.5, so here. So this one will approach these lines like that. And then on the other side, we have a +7. So up here somewhere, we'll say that's 7. And 3.5. 1, 2, so about here. And it's going to come this way. And it approaches the dotted lines. The other one, a linear over a linear. Let's hit the wrong one, darn it. It's pretty much the same. Only the horizontal asymptotes found a little bit differently. So vertical, horizontal asymptote, and plot 2 points on each side. Domain. 2x plus 3 equals 0. 2x equals a -3. X equals a -3/2. So x can be any value except for -3/2. These will not reduce, so that is also a vertical asymptote. The degree on the top and bottom are both 1. When that happens, our horizontal asymptote is y equals, when we take these two terms, the x's cancel, y equals 3/2. So the horizontal asymptote is at 3/2. So when we go to graph it, 1.5, so at 3/2 we have a horizontal. Our vertical is at a -3/2. 1.5. Okay. So we need to pick 2 points on each side. On this side, we can do -2 and -3. On this side, we could do 0 and 1. So if we plug in -2, (3x plus 3 divided by 2x plus 3). So if we plug in -2, we get 3. If we plug in -3, we get 2. If we plug in 0, we get 1. Oh, this works out nice. And we plug in 1, almost, we get 1.2. I wonder what. Okay. I also plugged in -1, which is a nice one because it gives us 0. So we're getting the intercepts. But you only needed 2. So if we plug in -2, 3, -2, 1, 2, 3, here, -3, 2, here. So it's going like this. The other side we have 0, 1. We have 1, 1.2 there. We have -1, 0. And this goes like this. And there's your graph. So you need to pick 2 on each side. Try one more. Okay, so we have this. Now when we're solving it, this is an x. We need to first find vertical and horizontal asymptotes. So I want to write nice on there. 2x plus 7. So our domain. Look at the denominator and find out what will get you 0. And that's a -2. So the domain is anything except for -2. Because this doesn't reduce, that is also our vertical asymptote. To find the horizontal asymptote, we look at the degree of the top and the bottom, and they're both the same. The degree of the top and the degree of the bottom is 1 because that's our exponent, our largest exponent. When they're the same, the horizontal asymptote is y equals, and you take those 2 largest degree terms and reduce them. The x's cancel and leave 2. So vertical at -2. Horizontal is at a +2. And then we want to pick two values on each side and plot them. So at -2 we can do -3 and -4. Going the other way, -1 and 0. So 2x plus 7 divided by x plus 2. And we're plugging in -3, -4, -1, and 0. So we have a -1, 1/2 or 0.5, 5, and 3.5. -3, -1, -3, -1, it's here. -4, and there's a half, so -4 1/2. -1, 5. 1, 2, 3, 4, 5. 0, 1, 2, 3, 3.5. So this one's coming here, going that way. This one is going here and going this way. Oops. And that's all there is to those.